This video covers the notes over geometric sequences. So if you remember, 2 days ago we talked about a sequence, which is just a list of numbers or objects that are in a special order. A geometric sequence is a sequence of numbers such that terms have a common ratio between them. And this means that it's being multiplied. Common ratio being multiplied or divided between them. So, when we look at some vocab, these things are the same as arithmetic sequences. A to the n is just an nth term, kind of like your unknown. We use x and n instead of x. A to the 1 is the first term, n is the term number, and d is the common ratio. So, example 1 wants us to write the first 5 terms of a geometric sequence with a first term of 2, so we're starting at 2. And each consecutive term is 4 times as much. So that ratio is 4 times. So 2 times 4 is 8. 8 times 4 is 32. And we can keep this going and going. 128 and 512. So I'm multiplying by 4 each time to get the next term. So in example 2, they've asked me to find the common difference of the sequence below. So when I go from 81 to 27, that gets considerably smaller. So if I take my ratio, maybe try to figure it out. So I have 27, and I went from 81 to 27. That gives me a ratio of 1/3. Let me try it again. So 9 divided by the term that was there previously. And that gives me the same thing. So my common ratio is 1/3. So if I take the first term and multiply it by that 1/3, I get the next term. If I do it again, I get the next term, and so on and so forth. So I can continue this sequence to find a of 7. So with that, I'm going to give you a formula. That should be, the formula part should be written up on the top part. So our formula is our starting and then the rate to the x minus 1. And that x minus 1, as well as the setup of the formula, is why these are geometric. So yesterday, or the day that if you watch the arithmetic sequences, those are adding because they're getting bigger by 2 or by 3, and you're adding to it every time. This is a geometric because you're multiplying. We can't add the same thing to get from 2 to 4 as we can to get from 8 to 32. Same thing here. So usually geometric sequences either grow or decay at a pretty significant rate to where you can't add or subtract the same things. Now we use this x minus 1 to make sure that we can get the right equation, okay? So geometric sequences are just a little bit weird, so just understand that instead of x or n, we use n minus 1. So for this one, if I wanted to write the formula, I start at 81. My rate we found was 1/3. And I'm going to plug this into y equals over here on my calculator. So I have 81 raised to the 1/3, sorry, 81 times 1/3, and this is going to be raised to the x minus 1, and you'll see why here in a second. So when I go to my table, let me turn off table ask. So when I go to my table, I can see the first term I see is 81. If you do not put this x minus 1 in there, if you just do x, it will not give you the same numbers in the same spots. Okay, so this is my first term, my second, third, and fourth. So my first term is 81, second is 27, third is 9, fourth is 3. So again, if you do not put that x minus 1, it will not give you the right numbers. Then to continue and find a to the 7, I'm going to go on my calculator. When a is 7, my value is 1/9. So in a geometric sequence, you do your starting, and remember this starting is my first term, so that's where the x minus 1 comes from, because this isn't my 0 term, this is my first term. So my first term times the rate raised to the x minus 1, so that my first term will actually show up where it needs to in the calculator. So for example 3, a sequence can be generated by using a to the n equals 5a(n minus 1), where a to the 1 is 2. What are the first 4 terms in this sequence? So a to the 1 is 2, and they want terms 1, 2, 3, and 4. What you can get from this equation is your rate. It's written in a different way, but all you really need is that number in front for the rate. So if I do starting, or A1, times my rate to the x minus 1, I'm starting at 2, my rate is 5, and this is raised to the x minus 1. Now I can plug this into the calculator to get the rest of my pieces. So 2 times 5 raised to the x minus 1. So if I go to my calculator, when x is 1, y is 2. And then 2 is 10. So that's 5 times the previous term. 3 is 50. And 4 is 250. Okay, this right here is just a fancy way of saying that for the term, they want you to take 5 and multiply it by the term before. So that's what the x minus 1 is doing. It's taking the term before it and multiplying it by that rate when given a starting value. So this is my rate times the previous term. So 2 times 5 is 10, times 5 is 50, times 5 is 250. This just looks funky, so if you will always turn it into an exponential function, then you'll be good to go. So example 4 wants the formula for the nth term of the sequence below. What is the common ratio? So my ratio to get from 2 to 6, I multiply by 3 times 3 times 3. So we're good to go on that common ratio. Some of these you can put them into stat edit if you aren't seeing it immediately. Just remember that you have to write your formula a little differently. Oh wait, term 1, 2, 3, and 4. And then my numbers are 2, 6, 18, and 54. So when I do stat calc, we're turning these into exponential regressions. So from this, oh, I made the mistake. So actually, when you put it in stat edit, you have to start at 0. Just trust me on that. But it's honestly easier if you just write it by hand. I start at 2. So remember, it's start times rate raised to the x minus 1. So I start at 2. My rate is being multiplied by 3. And this is raised to the x minus 1. No matter how you put it in stat edit, the rate you're really just looking for is that b value right here. The start may or may not work depending on how you put it in stat edit, so the easiest thing to do is just figure out your rate. You can figure out your rate by doing term 2 divided by term 1, or whichever the previous, so 6 divided by 2, 18 divided by 6. So when you're looking at two terms, take the later one and divide it by the one before it to figure out your term. Okay. Example 5, we're given the sequence, the common ratio. If we take 40 divided by 20, it doesn't matter which one we take, but take a term and divide it by the most previous term or the term before it, and you get 2. A to the 1 is 10. That's my first term. So my formula is start times rate raised to the x minus 1. So then to find the 10th term, I'm just going to plug that in. So 10 times 2 raised to the x minus 1. I'm going to go to the table, and the 10th term is 5,120. Now, example 6, my common difference here, you got to be a little careful with this one. 15 divided by -5. So I'm just taking a term and dividing it by the term before it. So 15 divided by -5 is a -3. My formula is start, so we start with -5, times my common difference, or my rate, so -3, raised to the x minus 1. And then I'm going to write that out here so that I can use the calculator to find the 5th term. Okay, so remember this number down here is the number you go to at x. A good thing to do is just double check, make sure that your table matches the sequence that you were given. So we have -5, 15, -45. That looks good. So the 5th term is -45. 405. Okay. And then example 7, they're giving us the first term and the ratio, and they want the first 5 terms. So our formula is our first term times our ratio raised to the x minus 1. You could also do this by hand if you feel more comfortable doing it that way, but I'm a calculator kind of person. So I have 2, 6, 18, 54, and 162. I'm just writing those first 5 terms, all listed as you see them.